So let's say they've given us two equations, or we've got to a point where we found two equations with an equation for a solution. The question comes up, is 323 pi over 9 a solution? Okay. And because these are periodic functions, it's very common to have two solutions because as you go on your Cartesian plane, within the period, it repeats a pattern, right? So if I'm going from here to here, then let's say I'm asking to when it hits this y point, we'll have this point and this point. We have two solutions to it. And then in the next period, those two solutions repeat. In the next period, those two solutions repeat. And this is kind of the repetitive part of the equation. Normally, they'd write something like, I'll write it below, n is an element of all integers, or n is an integer value. Okay, how do we solve this? Well, this is, what they're asking is theta equal to 323 pi over 9. They're asking this as a question. What we need to do is just some substitution. We're going to take this value, substitute it in for theta, and check what our n value is. We'll get a value. The question is, what is it? And then we'll do the same thing in the second one. Plug it in, check our n value. If n is an integer like 1, 2, 3, then this checks out. That's a terrible check mark because of this statement. N is an integer. If n ends up being like 0.23 repeated, then that doesn't work because that's not an integer value. Okay. So let's start by just plugging in. 323 pi over 9 is equal to, so we plug that in for theta, pi over 9 plus n times pi over 3. The goal here is to get n by itself. So I'm going to start by bringing over pi over 9. When we bring it over, we get 323 pi over 9. This comes over, becomes negative pi over 9. And you can think of it as like a negative 1. And that way we can think, oh, I just got to subtract those coefficients there, okay? And then on the right-hand side, we still have n times pi over 3. When I subtract these two values, that one's pretty straightforward. I just 323 subtract 1, I get 322. Pi over 9 is equal to n times pi over 3. Okay, I got to divide by a fraction. I can use my calculator to do divide by pi over 3, or I can use a little multiplication trick. Instead, I can multiply by the inverse, which is the exact same as dividing a fraction. I multiply by the inverse. On the right-hand side, this becomes pi over 3 pi over 3 pi, which is equal to 1, and 1 times anything. That's the whole goal. We're trying to create a 1. So this cancels out when we do it. On the other side, though, I get this unique scenario where I have a pi on the bottom because we're going to do numerators by each other and denominators by each other because it's fractional multiplication. These pi's, they cancel out. Okay. And this 3 can be reduced by this 9. That just becomes a 3. I had to do very little work there. I end up with n stays, so n. On this side, we have 322 over 3. Okay, this might be something I plug into a calculator, or I can do a little long division on the side here. 2 goes in once, goes in 0 times, 22. This goes in 7 times with remainder 1, or some decimal value. But this is what's key. Is my remainder 0 or not? In this case, I had a remainder 1, which means n is not an element of our integers. It's not an integer value. We could actually find out what it is. 21, 1, 0, 3 goes in 0.3, probably repeated, something like that. Not an integer value. So it doesn't exist on this one, but we did have two solutions. I'll go through this one a little quicker since we've done it once. But we have our other potential solution. Is 323 pi over 9 within the solutions for 2 pi over 9 plus n times pi over 3. Okay, this one I'm going to go faster. I'll bring the 2 over. We'll go 323 pi over 9 minus 2 pi over 9 equals n pi over 3. This becomes 321 pi over 9 is equal to n times pi over 3. To create a 1, I multiply by the inverse. And I just make sure I do it to both sides, okay? That cancels out. These cancel out. That reduces. This becomes 3. So much quick work there. 3, 2, 1 over 3. And I'm going to tell you that that is going to work just because of the other long division, but we'll write it on the side. 3, 2, 1. Nice number. 1 becomes a 0. 0 times into 2. Does 3 go into 21? Yeah, it goes in 7 times. No remainder. So n equals 107. That checks out. So that is one of the solutions. So if they ask us, is this a solution? Yeah, it is. It is a solution. It's a solution to that second one we had. Good, it all fits. It's a solution here. So I will cross through that. Oh my gosh, where's the value? Here it is. I will cross through this value within that period of the solution.